Okay, so we are going to build equivalent expressions using quadrilaterals. And this quadrilateral is going to be a square. All right, so you know a square has the same sides. We're going to do a square and we're going to do a rectangle too. All right, so let's do the square first. I have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then I'm going to connect them here. So I have a square. I don't know if that's a square or not. I feel like that's a rectangle. Yeah, definitely a rectangle. Let's see if I can draw an actual square this time. Okay. So I'm going to say that this is a rectangle and this is a square. This one is a rectangle and this one is a square. Let's do the square first. The square has side lengths that are x plus 3. And the rectangle has side lengths that are 2x plus 5. And we're going to write all of the equivalent expressions that we can for each one of those. We're going to start with the square first. When we're trying to find the perimeter of each figure, writing the equivalent expressions. So if we start with the square first and we do the expanded form of the expressions, we know that since it is a square, all of the sides are the same. We want to make at least 4 equivalent expressions, but it's possible to make more than that. So the first one that we're going to make is x plus 3 plus x plus 3 plus x plus 3 plus x plus 3. Although they only have one side listed, we know that there are 4 sides to the square. So we write the same expression 4 times. Okay, now, the next step is we can write it with parentheses. I like to call it the parenthetical expression. Give it to me. 4 times x plus 3. Okay. The next expression we can write is the one where we distribute. What do we get when we distribute? All right, tell me, Leo. 4x plus 12. So we have 1, 2, 3 equivalent expressions. Now, if we want to get silly with it, we could break down 12 and say that we could have 2x plus 2x plus 8 plus 4. But I think these are enough expressions for the square. Do you all see anything else that we could do for these expressions? I think we've exhausted all of our normal possibilities for the square. Let's go up to the rectangle. And let's do the same thing. Look up to check your work because at this point I'm expecting you to already know how to do it, okay? All right, so let's go. First, the expanded version. Okay, now I counted them because I wanted to. Oh, yeah. Okay, we need another side, huh? All right, so let me delete this. And let's call this side x plus 2. Now we can work. Say that again. All right, let's clean it up. What do we get? You can tell me. Okay. Now, I think there's another way to write this one that we did not write yesterday. We could take this same expression and we can write it with just 1, 2. And we could say that it is 2 times both of these in the same set of parentheses. Uh-huh. 2x plus 5 plus x plus 2. That's another expression that would be equivalent to 1 and 2. So do you all see the parts that I put within these parentheses right here? Although it's 2 2's right here, I can put 1 2 and the same effect will still happen. Okay, so then that's how we're going to end up with maybe 5 or 6 different expressions for the rectangle. Because we can take number 2 and distribute. Look up to check your work where you distribute number 2. And then for number 5, look up to check your work where you distribute number 3. And then I think number 6 will be the most simplified version of it all for the perimeter. So this one will take 2 and distribute to 4. For this one, we'll take 3 and distribute to 5. And then 6 will be the most simplified. All right. And don't forget, when it comes to combining like terms, you can only combine the terms that are alike. If you have 4 x's and 2 x's, then you have a total of 6 x's. And then the constants here that are 10 and 4, that's like saying you have $10 and $4, but then you have 4 x's and 2 x's. You can't really put all of that together and count it as one item because those are 2 different unique items. You got x's and dollars, like that's 2 different things. All right, so here's what I have for number 4. 4x plus 10 plus 2x plus 4. And a lot of times, mathematicians will forget to distribute to both items in the parentheses. So do not forget to distribute to both items in the parentheses here. And then for number 3, for 5, I'm going to end up with the same expression. So I really don't need a 5. I'm going to cross out 5 because it's going to be the same expression. And so then all we need is number 6, where we combine the like terms, which end up being, let me hear it. Okay, now, if I asked you to evaluate both of these figures for x equals 2. Evaluate means substitute and solve. Take a moment and evaluate when x equals 2 for both of these, and let me know what you get. I think this one, and this one. Do you all agree? All right. So now, what you are going to do is you're going to create an art project with the last half of your paper. You're going to get the scissors. You're going to keep the top half. The bottom half, you are going to build either a square or a rectangle with a marker. You're going to label it with your own dimensions. If it is a square, it only has one side label. If it is a rectangle, it has two sides labeled. And you're going to come up with 3 to 5 expressions for your figure. And you're going to turn it in today. Do you understand? All right, so you know where the scissors are? Are they out? We'll pull the scissors out. You'll get a marker, make your figure, and create your expressions and get it turned in.